Look at how to use the enthalpy of solution to figure out the final temperature after some sort of compound is dissolved in water. All right, so in this problem, 24.8 grams of sodium chloride is dissolved in 250 milliliters of water. That's originally at 25. We're looking for the final temperature after it's been dissolved. Well, if you look here, it gives you the enthalpy of solution. Sometimes people call it the heat of solution. It gives you that right there, but it's in kilojoules per mole. What that means is we've got to change this grams to moles, because what this says is that this sodium chloride will absorb. See, it's a positive. That means it's an endothermic process. It's going to absorb 3.88 kilojoules for every mole that's dissolved. It's going to absorb that from the water. So first of all, let's change it to moles. So we're going to take our 24.80 grams of sodium chloride and we're going to change it to moles. And so in 1 mole of sodium chloride, let's see, there's about 58.43 grams of sodium chloride. So that's going to equal about 0.424, something like that. 0.424, we'll just stop there. 0.424 moles. Okay, now the next thing is we're going to use this enthalpy of solution to figure out how many joules this is going to release. All right, so we're going to take this 0.424 moles and we're going to say it's going to absorb, I might have said release earlier, but it's going to absorb 3.88 kilojoules for every 1 mole that's dissolved. Now, we're going to be doing a using the Q equals MC delta T down below, and that needs to be in joules, so I'm just going to go ahead and do one more step, and I'm going to end up changing it to joules right here. So in 1 kilojoule, there's 1,000 joules. And so if you do the math right there, you get something like 1647 joules. So that many joules, and our number is positive, it's going to be absorbing it from the surroundings, which will be the water. All right, now what we're going to do is we're going to use this formula Q equals MC delta T, but we're going to solve for delta T. And so I'm going to rearrange this equation, and I'm going to get that delta T is equal to Q. Oh, that's wrong. So what I'm going to do is say delta T, I meant to write an equal sign, is equal to Q over MC. So then I'm going to plug in my numbers. Delta T is equal to my Q, which is 1647 joules. I'm going to divide that by the mass. Now, one thing about the mass, whenever you're doing solution types of problems like this, you have to take the mass of the solute, which is 24.80 grams, that's the sodium chloride, plus the mass of the water. And you add that all together. So I get 274.8 grams is what we would use. So we're going to plug in down here 274.8 grams. And in this problem, we're just going to use the specific heat of water, which is 4.18 joules per gram degrees Celsius. All right, so our joules will cancel, our grams will cancel once we do the math, leaving us with a change in temperature. So if you do the math there, you end up getting that the change of temperature is 1.43 degrees Celsius. Now, the part that I find a lot of people have trouble with is knowing what to do next. And so the water is originally at 25 degrees Celsius. But the trick is that temperature going to go up or is it going to go down? As you can see, our enthalpy of solution is a positive number, which means that it's endothermic. So when, you can think of it like this, when the salt is dissolving in the water, you can think of the heat energy is going to have to go in, and so that's going to lower the temperature of the water or the surroundings. That's what we're measuring. So the temperature is actually going to go down. So what we're going to do is we're going to take this 25.0 degrees Celsius and we're going to subtract 1.43. And what we end up getting is we end up getting 23.6 is the final answer. So that's our final answer. All right, I hope that works for you there, that you can figure out how to do one of those problems.